In this video, we're going to see that how we can merge these linked lists together. So these linked lists are given in an ascending order, you can see. And we need to merge all of these linked lists and create a new linked list which will be containing all of these nodes in an ascending order. So there can be many approaches to do this question. So the approach that we're going to see today is going to be a pairwise merging approach. So if you didn't understand that how these linked lists are fitting into an array, so actually these are like this whole linked list looks something like this. It's like this 2 is pointing to 3, and then 7, and then we have this 4 is pointing to 5, and then you have this 1, then 5, then 9, and then 11. And another one is 2 is pointing to 6. So these linked lists are given in an array. So the whole linked list is not given, only the head is given. So the head of this will going to be ARR 0, you can say. The head of this will going to be ARR 1. The head of this will going to be ARR 2, and the head of this will going to be ARR 3. So the final array will be looking like this, that ARR 0, ARR 1, and this ARR 2, ARR 3. So you can say this thing that ARR I is actually storing the address of head of one linked list. Okay. So this is our question. This is an array given, and there are these arrays given inside of it. So it's not like that this whole array is actually given inside of it. There's no another array. It's just the address. Okay. So this ARR 0 here is actually storing the address here of this linked list, like this head of this linked list. This ARR 1 here, which is going to be here, is storing the address of the head of this linked list, so on for these. So this is what's going to be given to us. So there can be k number of linked list. Okay, so right now the k value here is, we have 4. So what is the approach we're going to use here? So what is the approach that we're going to use here to solve this? So as I said, that we will be using a pairwise merging approach. Okay, what is this approach? So if you probably had did question in which you have given a linked list, you have given 2 linked lists. One is this one, and let's say one is this, and these 2 linked lists are given in ascending order, and the question says to you to merge these together and to bring up a new linked list which will also going to be in ascending order. Okay, so how we were actually doing this thing? So we were actually taking up pointers. For example, our first pointer will be here, then another pointer will be here, and we were taking a dummy node. Okay, so we're going to take a dummy node here. So let's say the dummy node contains 0, and we keep a pointer on this also. So what we were doing is actually that we were comparing this value with this value. So which one is smaller? Okay, so we're comparing this 2 with this 1. So which one is smaller? We can see this 1 is smaller. So as soon as we find out that this thing, that after comparison, if you find out this thing that this one is smaller, then we simply just use to attach this thing right here. What is the benefit of that? Okay, so we're gonna attach this dummy node over here, which is gonna look like this. Our pointer is here. So now our dummy node points to this second linked list. Now we're gonna move our pointer ahead, and we're gonna make it come here. Now we're gonna compare again this 2 with 5. So now we find out this thing that 2 is smaller than 5, and now we're gonna take this whole node. Like before even moving this whole node from one linked list to another one, you need to move this pointer also, and you need to make sure this pointer always points to this pointer. or this pointer in this linked list. So let's see what I'm actually trying to say. So firstly, I'm going to remove this pointer and I'm going to move it ahead. As I attached it, I'm going to move the pointer ahead. So it will going to come here. Now, as I compare this 5 with 2, this 2 is smaller, so I'm going to take this 0 and 1, I'm going to put it here. So I'm going to rub this from here. I'm going to take this and I'm going to put it here instead. Okay. Our pointer is here. So now we can see that our 0, 1 is pointing to the first linked list because we found out that 2 is smaller than 5. Now, as soon as we attach the dummy node list, we're going to move the pointer ahead. This pointer will going to come here and going to get removed from here. And now we're going to compare this pointer with this thing, or like this node with this thing. So we can see that our 3 here is smaller than 5. This 3 here is smaller than 5. So now it will not going to come here. It will going to stay this linked list that we are creating with this dummy node. We're going to stay in the same list because we don't need to move anywhere because 3 is already smaller than 5. We're not going to move. We're not going to move this here. So, but we're going to move our, because comparison is done, and we're going to move this, our pointer from here to the next node. And our pointer will going to come here. We're going to compare this again. So now this 4, we're going to compare with 5 again. We found out this thing that this is still smaller, and our linked list will not going to move still. It's still going to stay here. Okay. Now we're still going to move ahead here to 5, and we're going to compare. So now it's equal. Okay. In the case of equal also, you need to do the same thing. You don't need to move. Okay. You just need to attach it. Okay. So you're just going to keep again here. Now this pointer will going to move ahead as this is our last node. This is the last node. Like after this, it's null. It's null. So this pointer will going to move to null now. This pointer will going to come here, and this pointer will going to move. As soon as you find out this thing that the pointer is pointing to null in any list, that in the second list there are some nodes still left to compare, that means that these nodes will be coming to the last of this. So what you can do is here that you can remove this and you can take this pointer and attach it here. Take this and attach it here. So that's what we're gonna do. We're gonna take this and we're gonna attach it here. Okay. Done. So we can see our linked list is completed, and this new linked list is actually containing all of the nodes in ascending order. So you really understood this thing, that why we attached this here. The thing is that we found out this thing. So let's go back a little. We're gonna take it here. So this was our case, right? And it was null here. It was null here. And our pointer was here after comparing all of these. But now we cannot compare anything with null. And we know this thing that in our second list, some elements are left to compare. But we know this thing that if these elements weren't smaller here, then obviously they are greater than the last value. We found out this thing that this 5 is equal. So if we take this whole linked list and put this here, or if we just keep it there, both are same things because 5 and 5 are equal. And now if we even move to 8, we know this thing that 8 always going to be greater than 5. And if it's greater than 5, then obviously it's going to come in this list also after the last node. So that's why we took this all. So that's why we took this all and put it here. Okay. So that's why we took this all, and now we're going to put it here on the back. And now we can see, well, it was already pointing to null here also. So we're going to point this to null. Now you can see our linked list is completed. So why we did this? This is the pairwise that like we made. So this is what we're going to use in our approach. As in our question, there are multiple linked lists. Okay. So what if we do one thing? We take this linked list and we compare, okay, not compare. What if we take this linked list and this linked list and merge both of these by using the same method as I discussed this one. We do this with this linked list and this linked list. And after that, whatever the resultant linked list gonna be, we're gonna take that and we're gonna do that same thing with this linked list. What I'm saying? So let's see. So firstly, remove all of the pointers from here. So we were having these two linked lists. We merged these and we got this new linked list. Now, let's say we have a one more linked list that also we need to include in the here, right? So we're going to take another linked list, 6, 9. So let's say our linked list only contains 2 nodes. And now our 2 linked lists got merged. Now this is our third one. So obviously we will gonna take this linked list and we have to merge this linked list in our resultant linked list of first 2. So we're gonna do the same thing. We're gonna take a pointer, one pointer here and one pointer here. Why we are not taking pointer here? The reason behind that is that we have to delete this. Like we were having 2 linked lists and we got this as our result. This is a whole linked list and this have this dummy node. Okay, we have to create a new dummy node every time we will gonna take another 2 linked list. Okay, right now we just gonna assume that this is our new linked list and this is our new linked list and we have to merge both of these. So to merge, we're gonna take this dummy node back again, a new one, not this one. So we're gonna delete this from here. We're not gonna include this in here. So the same thing we're gonna do, we're gonna create a new dummy node, let's say 0. And we will gonna attach this wherever it will gonna find smaller node. We're gonna compare this again, 1 with 6. Which one is smaller? This one is smaller, 1 is smaller. So this dummy node will gonna move there. So we're gonna attach the dummy node here with the head of the first linked list. And now this pointer will gonna move ahead. It will gonna come here and we're gonna compare these nodes again. So now 2 to 6, 2 is smaller. So it will gonna stay here. It will not gonna move anywhere. Our pointer will gonna move. So the pointer will gonna move here. We're gonna compare this 3 to 6. We found out that 3 is smaller, so it's still gonna be here. The dummy node is still gonna be attached to the first node. And now we're gonna move this ahead again. We're gonna compare this 4 and 6 again. And we find out that this is still smaller. We're not gonna move. We're gonna move the pointer instead. The pointer will gonna move here. We found out that 5 is still smaller. We gonna move ahead. Again 5 smaller. Okay. Now in the end, when we're gonna move to 8, we're gonna see that now 6 is smaller. So in the second list, our element is smaller. Now, as we discussed that as soon as we find out a smaller number in any linked list, we're gonna take the dummy node 1 list and we're gonna attach that to that one. So we were having a pointer to the dummy node also. As soon as we were moving this pointer here, that pointer was also moving. So we had to take it at when we created this dummy node, we were having a pointer on the top, and as soon as we were moving this pointer should also move. So accordingly, this pointer should be at somewhere here, at the last of this dummy node before we compare, right before we compare. So now we're gonna take this whole list. Now we're gonna shift this here, okay, and we're gonna connect this 5 to 6. So now you can see that our dummy node list got attached to the second list because this 6 was smaller than 8. Now we can simply remove this arrow also. Now we're gonna compare again with 8 and 6. So like we attached here, like our dummy node list is attached here to 6. So like 6 comparison is done. Now we're gonna move ahead this pointer here on 9 and we're gonna compare with 8 again. So now we're gonna compare this 9 with 8 and we found out that 8 is smaller. So so as soon as we moved this pointer here, this pointer should also gonna move. It will always gonna follow this and it's always gonna be behind the pointer in any list. Like if this list is here, then this pointer should be following this pointer, and now it's here, so this pointer should be present on 6. So we're gonna make this move here, because this will gonna help us attaching this list over into any list. So now we're gonna do this again. We're gonna take this whole list and we're gonna move it here. Okay, so now as we can see here that our comparison with our comparison with 8 is done, and our list, our dummy list, our dummy node list is actually attached to the 8. So now we're going to move this pointer ahead. Okay, so after moving this pointer ahead, we're going to point to null. And I told you this thing that as soon as any of the pointer in any list points to null, we're just gonna stop checking, stop comparing, because we cannot compare any value with null. Okay, so if in the first list as the pointer had gone to null, that means in the second list this here will always going to be greater than the last node of the first list. As we can also see here that this 9 is always going to be greater than 8, which it is. And now here we're gonna attach this whole node here. So now we're gonna attach this whole node here. Firstly, we can remove the pointer now. Now we're gonna take this and I'm gonna attach here. Okay, and this pointer will also gonna move at here. Okay, so this is going to be our approach, right? So at this particular moment we were able to merge 3 linked lists, right? So that's how we have to do in this case also. So you merge this and this together, then after that you have to merge whatever the result of this going to be with this list, and whatever the result of these 3 going to be, you have to take that and you have to attach here. So you have to merge with this one. Okay, so let's see how the code gonna look like of this. This looks pretty complex, but it's not really that. So the first thing that we're actually gonna do is we're gonna create a function, because we have to merge 2 lists every time. So we can see here that we have to firstly merge this with merge this with this. Then the result of this is also going to be a linked list. And we have to take the result. We have to merge with this also. Then we have to take the result of these 3, and we have to merge that with this. So we're merging again and again. So instead of writing the merge code again and again for every list, we're simply gonna make up a function which will gonna do the work, and we just simply can call that in our while loop to repeat the process of merging. So how our function gonna look like? So we can see this thing that our function is always returning a list. So when you're merging this list with this list, you're actually getting a resultant also as a list, right? So that's what I wanted to say, that our resultant will going to be a list node star. Okay, so we're gonna call this function as merge, and we're gonna write inside of this those 2 lists. We're gonna pass those 2 lists. So let's say that is list 1, and another one is list node star list 2, our second list. Okay, so we're gonna start our function. So what's the first thing we're gonna write in our function? Okay, let's take 2 linked lists again. Let's go step by step. Let's say you have these 2, 3, and then 7, and this points to null. This is our first list. And let's say you have 1, then 5, and then it points to null. These are the 2 lists that you need to merge. So the first thing that we were doing, we were creating a dummy node so that we can attach to the node which is smaller, and we were comparing them. So to create a dummy node, we're gonna write list node star dummy equals to new list node, and we're gonna write 0 inside of it. You can take a negative number also, whatever you like, but prefer 0. So the next thing we were doing, that we were attaching, so this dummy node is created here. So we have to attach this dummy node to whichever these nodes will going to be smaller. So we're gonna see here that this 2, as we can see here that so now we're gonna compare this 2 with 1, and we can find out, so we find out this thing that 1 is smaller than 2. So this dummy node should get attached here. So we're gonna take this dummy node and we're gonna attach it here, wherever so even before this we were having some pointers here, that's how we are able to compare. So we find out this thing that 1 is smaller, so in the second list our node is smaller, so we attach the dummy node to that. For the purpose of comparing, we actually gonna write here. So before even going to comparing, you need to give name to these pointers. So let's say this pointer name is current1, and this pointer name is current2, and the pointer that is pointing to the node, let's say that called as a tail. Okay. So this is our first step. We named our pointers, and now we need to compare the values. So we're gonna see that current1 value is smaller or equals to current2. Even if it's smaller, like even if it's equal, we still gonna attach our dummy node to that list. So as soon as you find out this thing that current1's value is smaller than the current2 value, or it is equal, we're simply gonna take our dummy node and we're gonna attach it to that pointer. So we were having our dummy node, this dummy node that is tail, and this tail's next is going to be current1. Okay. In this particular case, our current2 is smaller, so in that case we can also write that else if current2's is smaller than equals to the current1 we simply gonna attach the tail next to the current2, right? So we did this for both of them, and this one is good for this thing. As current2 was smaller, we took our dummy node, and tail is the pointer that is pointing to it, and after that we simply attach our tails next to the current node. Like this is the next of this tail, and we attach it to the current node. This is the current2. So our comparison is done. As soon as our comparison is done and we were successfully able to attach to whichever list we have attached our tail, we're gonna move that current ahead. Okay, so we're gonna move this current2 ahead because now this is attached. So this current2 we're gonna move ahead, so we can write current2 is next. So this is the current2 next, this 5 is the current2 next. So now the current2 will gonna move from here to here, which is the next of the current. So current2 is equals to current2 next, and we can simply assign our current2 here. Okay, we're gonna do the same thing for this also, as if we are able to find that our current1 is smaller than current2, we're simply gonna attach our tails next to the current1, and we're gonna move our current1 also ahead. So current1 will going to be current1's next, and we're gonna close this. We can close this. So these are the condition that how you're gonna do after comparison, how you're gonna attach the dummy node. Okay, so let's move ahead, and after that we're gonna compare this 2 and 5. So now we got our first case. Now this 2 is smaller than 5. Okay, now you probably will like that why we are not moving this current ahead, because our dummy node is not attached here. This thing can also, like, we only have to move our current to that node where we know that in that list our dummy node is present. So dummy node is here, so we're gonna move this current2. The comparison for this one is done, but for this 2 it is possible that there will be nodes which will be smaller than 2 in this list. So we can take those nodes and we can put them here. If we're gonna move ahead, we will not gonna be able to do that. So you only have to move ahead as soon as you find out that your dummy node is present in that list. So now we come after comparing 2 and 5, finds out that this 2 is smaller. So we're going to take this till here to here. And one more thing that I told you before that I always forget, that you have to move this tail node also ahead by any means. Doesn't matter, even if it's going to be here, you still have to move the tail. So just after you move the current pointers, you simply can move the tail also. So you can write here tail is equals to tails next, and here also you can write tail is equals to tails next. So when we compare this 2 with 1 and we will find out this 1 is smaller, so we attach the semi node here. Now this tail will also going to move here, the tail equals to tails next. So we're going to move this tail, we're going to remove this tail, and we're going to move it here. This is going to be our tail. Now we compare this, and this 2 is smaller, so this whole thing till tail, we're going to attach it here. So we're going to take this whole thing and we're going to pull it here. Okay, so now we can see that our dummy node is successfully attached to the smaller node in the new list. So we can move this current one ahead now. So we can move this current one ahead. Okay, we move this current one ahead, and now we're going to compare this again, 3 with 5. So now we find out that again 3 is smaller, so we will not going to move anywhere. We're going to move this tail first. We move the tail, and now we're going to move our this current here. This current is going to be 1, and this tail also. Again, this tail should always be behind this current pointer. Doesn't matter here, doesn't matter here, this tail should always be behind, because that's how you're gonna attach the node. If you don't have the access to tail, how are you gonna be able to take this linked list from here and transfer it here? Tail, you are taking the tails next and you are attaching that to the current. If you don't have this tail, you will not gonna be attached this here if it is smaller. So as we found out, as we moved our current and tail ahead, we're gonna compare again. So now we're gonna compare again this current 1 to this current 2. Our current 2 is smaller again. This loop will gonna execute. Tails next will gonna become current 2. So this is the tails next. We're gonna take our tail from here. So we attached our list with the dummy node to the new node now. So now we can move this current ahead. When we're gonna move this current ahead, the current will gonna come here. So now I told you this thing that as soon as you find out that any of the current pointer points to null, just stop that. Okay, you will not gonna compare anymore. So we can simply write in our while loop here that while you have to do these comparisons until the current one is not null and the current 2 is not null. And like if any of these conditions get false, we will gonna come out of the loop. So as we can see that our current 2 points to null, and this loop should only execute when current 2 is not equals to null, but it points to null, so this became false. Now this is 0. One input is 0, this whole going to be 0, so while is false, it will not gonna execute anymore. So this is going to be our while loop condition. So as we can see, our current 2 points to null, but our current 1 still have 1 node left. And if we compare this 7 with this last node of this null list, so like this current 2 points to null, this is the last node. So we compare this 5 with 7. 7 is always going to be greater. If there would be like more nodes after this, they're always going to be greater than this because the lists are in ascending order. So what do we need to do? That we need to take this current one and we have to attach this just after this 5. So that we're gonna do here, we're gonna remove this and we're gonna take this from here and we're gonna attach this here. So this is our list. So this is our list. came. So this is our new list came. Okay, so how are we gonna do this in the code? So we can write here that if current 2 becomes null and current 1 is not equals to null, we're simply gonna write inside that take the tails next, tails next, and attach it to the whatever left. Okay, so this current one is not null. That means that we need to attach that to our tails next. That's what we did here. Now, what can be the other case? What if the current 1 is null and the current 2 have some values? You have to do the same thing. You have to attach the current 2 with the current 1. So in the else if condition, if the current 1 equals to null and the current 2 is not equals to null, well, this is totally optional to write. Like, this line is optional to write. If you're not gonna write this, still gonna work, because both lists cannot become null at the same time. It's even if it becomes null, it's gonna be totally normal. Okay, and now we have to take our tails next and we have to attach it to our current 2. We discussed this case before in which our current 2 became in which our current 1 became null and our current 2 was having some values left, so we attached our current 2, all of it, to the current 1, because whatever left part gonna be, it's always going to be greater than the first list last node. The first list last node is always going to be smaller than the leftover part. Okay, so that's why we're doing this tails next equals to current 2. So this all will going to be our function. You need to do one more thing that you created a dummy node here, as we created a dummy node here. This is the dummy node. So when you do these, like when you do this merging, when you merge 2 lists, you need to delete the dummy node also in the end. So to delete the dummy node, you need to do one thing. Just create a pointer. Just create a new pointer as list node star result equals to, and call this as dummies next. And after that, simply delete the dummy and return the result. So what did I do here? Okay, so we were having this dummy node. This is our dummy node, this is our dummy node, and this is our dummies next. Okay, I'm taking a pointer which is pointing to the dummies next, which I took as a result. Right, result is my pointer, name of the pointer, which is pointing to the dummies next. So now if I delete this dummy from here and if I return this result is behaving as the head of the list, and if I return this result, this will gonna return the whole list, and our dummy is also deleted. So that's what we did here. We took a new pointer which is pointing to dummies next, and we deleted the dummy then, and then we returned the result, and here the result is behaving as the head of the node, the new list, sorry. So this is all going to be our function. This is the end of our function. So now how we actually gonna implement this function on all of the lists which are given in an array. So in the array, as I told you, that in an array, the array that is given, they have gave the address. Okay, so if 0, 1, 2, 3 is there, and here the 0 is actually pointing to the address of the list, of the head of the list. So this is a list, this is a list, this is a list, and this is a list, right? And I have to do this again and again. And so what I'm gonna do here, I'm gonna enable my function as merge. So this is our name of the function. This is the name of our function, merge list nodes. We're passing 2 lists here, and we're returning a list again. In the end, we have to return a result. We have to return the list. Okay, so this is our merge function. In this merge function, the first thing that I'm gonna do is that I'm gonna pass the head of this list, of this list and this list. Okay, so to do that, I can simply say, so let's say the name of this array is lists, and what I'm gonna do is that I'm gonna take the list 0, and I'm gonna take the list 1, and I'm going to send it to this merge function, and after that it will going to return me a new list, and I will call that list as, so I can create a, so I can basically create a new pointer, list node star, and let's call that list as a sort list. Okay, so this is a pointer which will be storing the head. So like, see, in here we saw this thing that we will returning the result, and this result that we are returning is actually behaving as the head of the new list that we created. So in the end our function will gonna return the head basically of the new list. So we can store that head here in this start list pointer. So now whatever going to be the resultant list, we have to take that list and we have to pass that list again here at this position with the another list. So what I'm actually saying, so we send it here, we send it here 0 and 1. After sending 0 and 1, we got this sort list. So we got a new list, and which is the sort list, right? Now we need to take this sort list, we need to take this sort list, and we have to send this list with now this second one, like this list 2. Okay, so now we have to send this with second one, right? So how are we gonna do that? We cannot actually take this 0 and 1, we're gonna use here I. So instead of writing this whole, we simply gonna, so now we simply gonna sort this out. What are we actually gonna write here, that we're gonna take a pointer now. So we took our pointer that was list node star and sort list. So at first we're gonna assume that our first list is already sorted, so we can simply write 0. Okay, so this one list here is already sorted, we assumed this is a sorted list. In the function I can simply write merge sort list, this is the head of the list, and this list I, and after that this will gonna return me a sort list again. This is very confusing. Let's see what I'm actually trying to do here. So we assume this thing that our first list is already sorted, and then we took that list, we took this list, and we sended that with this one. Okay, this is our second list, this is our first list, this is our second list. So we sended this sort list which we assumed with this list. After, when these will gonna get sorted outside, this will gonna get merged, these both will gonna get merged, they will gonna return another list which is going to be sorted again, and we have to take that list, we have to take this list again, and we have to take this list again with the next one, which is this third one. Okay, that's why we used I here. So as soon as we do this, we're gonna increase our I also, I plus plus, and we gonna use here a while loop, because we have to do this thing again and again. So we're gonna use here a while loop. In the while loop we're gonna write until this I is not equals to the list size. Now what this line actually mean here, that why we are saying that we had to do this I not equals to, this thing that we were doing, we were assuming that our first list is already sorted. We have to do this outside of the loop, not inside of the loop. Okay, and we're gonna initialize a I also, initialize I equals to 1, because the first list that we're gonna compare is going to be our one list. So like, if I assume that we have lists equals to this 0, then 1, then 2, and these are the list, the name of the list, you can say. So these are the addresses of the list, 0th address for, so there's an add, so these are storing the address. Okay, so at first we're gonna take this I is 1, so this I will going to be 1 here at first, this is first here, And this sort list, as we had saw that this is our list 0. So now we have sent it this and this both, and our result is sort list again. So this is like this got to a new list. So now this became a new list, which is sort list. Now this sort list will gonna handle this now. So now I is increased again, I came back again. Now this I became 2, this I is 2. Now this will gonna do the same thing here. This and this will gonna get sorted out, and it will still gonna return you a sort list again. So we can write here, this is the sort list. Now the I will gonna increase, I increased, now this became 3 here, and this 3 and the sort list, as we can see, we're gonna go again, and we're gonna return a list, which is going to be our sort list. So this sort list is what we need to return. Okay, so now we can see here that I, after passing the last list, so this 3 is our last list, and as soon as we're gonna come out of the loop, this I will gonna become 4, right? I is 4. So we saw this thing that in list we were having 0, 1, 2, 3. So we were having 4 elements, 1. So we were having 4 elements, 1, 2, 3, and 4. And in the end, this I became 4. That means it became equal to the size of the list. What is the size of the list? That is 4, and I's also became 4. And now there's no more there's no more list left to merge. So we simply gonna stop our while loop when I will gonna become the equal to the size of the list. This is the whole logic. Okay. In the end, you can simply return this sort list. And this is going to be your code. And this whole thing is going to be your code for this question. So let's see on Leetcode how we do this correctly. So we can see now this is our question, merge k sorted list. So in an array you will be given k list, k number of lists. You just need to sort them. So you just need to merge them one by one. So let's see the code. So whatever the code we saw earlier, we're just gonna write that here. So the first thing that we were doing is we were creating a function. So we're gonna create a function first. Our function was returning a list, and we're gonna call our function as merge, and we're gonna write inside, we're gonna pass 2 lists here. Let's call list 1, and another list is going to be list 2. Okay, after this, the first thing that we were doing is we were making a dummy node. So list node star dummy is equals to new list node 0. We assign 0 into this. After that, we were comparing that which one is smaller. Before even comparing, we were assigning pointers also. So you have to take pointers like list node current 1, which is pointing to the head of the list 1, and we were taking another pointer like current 2, which is pointing to the list 2 head, and there were one more pointer that we were taking to attach our dummy node list to the required list. Wherever you're gonna find the smaller node, you're gonna attach that. So we were doing that with the tail, and this tail is right now pointing to the dummy. After declaring the pointers, you need to compare the values of these pointers. Like if the current one well is smaller or equals to the current 2 well, then means you just need to attach this tails next to the current 1, and after that you simply need to move ahead the current 1 equals to current 1 next, and after that you have to move the tail also. Tail is always going to be following this current, and so this is for if in the first list you get a small value. What if you get small value in the second list? So if the value in the second list is smaller and equals to the value in the current list, we're gonna write here, and after that we're simply gonna write tails next is equals to current 2. We're gonna attach that tail to now current 2, and now we're gonna move our current 2 ahead to compare other nodes also, and now we're gonna move our tail also ahead. So we did this now, okay, and this thing we need to do in a while loop. So our while loop will be going until one of them becomes null. If it becomes null, we don't need to compare anything with anything. So if our current 1 become null and current 2 is not equals to null. So you have to run this until these are not null. Okay. After this loop, one of them will going to be null. So we have to check that. So if you finds out that current 1 is equals to null and current 2 is not equals to null, you simply have to assign that tails next will gonna become the current 2. Okay, in the else condition, else if this current 2 is equals to null and current 1 is not equals to null, you simply have to assign that tails next to this current 1. Okay, after this you did this, you need to delete the dummy node also. So to delete the dummy node, we use a method where we create a pointer which points to the dummies next, and after that we simply use the function delete to delete the dummy node, and after that we just simply return our result. Okay, we discussed this why we do this, and this is going to be our function for merging two lists. In here we just have to write 2-3 simple lines. Like firstly we need to declare a function as sort. We're gonna assume that our first list in the array is already sorted, so list 0, we're gonna assume that it's already sorted. We're gonna declare a variable I which is going to be equals to 1, and we're gonna start our while loop, and it's gonna run until this I is not equals to the size of this list array. This is an array. To do this until it becomes to the size of the array, until it doesn't become to this list size of this list array. Inside of this we're gonna write that this sort list is equals to, we're gonna call our function, and we're gonna write inside sort list, which is our initially, which is our the first initially, which is at the 0th index, and we have to do this thing with the ith is 1 at initially, and we're gonna increase our I. Okay, in the end we're simply gonna return our sort list. Okay, and there can be two edge cases here. Edge case is possible that what if your list is empty. So to check if the list is empty, we're gonna write equals to. If it is equals to 0, that means there's no linked list inside of this array. So there's no list, we don't need to compare, we can simply return null in that case. In the else case, else. So in the else, if another case, if you find out that there's only just one list inside of the array, if there's only one list, that means we don't need to compare that with another list to merge it. We're simply going to return that list. So return list 0, return the first list. So this is our code. Let's see if it runs or not. So we can see our code is accepted. These were the linked lists that were given inside of an array, and after that they merged them. When the list was empty, you just had to return null. So let's see after what we get after submission. So you can see our code is accepted here also. So hope you like it. I'll see you. So there are other ways to do this. There are optimal ways to do it. This one is kind of brute force, and for the purpose of doing this in an optimal way, we uses a min heap, or we uses a merge short to do that. So we're gonna see that in next videos, how we can use min heap and merge short to do this question.